Okay, so this is for trial test number 1, and it's question number 6, B, C, and D. And part of the issue here is that I don't know what values A and B are. But what I do know is this is a degree 3. This negative on the x will make it a negative degree 3. So it will start up here and finish down here. It will have a bounce at x equals minus a, and I'll have a cut at x equals b. Okay, I know that a is smaller than b, so if I call that a and I call that b, minus a will be over here. So I've got a bounce at minus a, so we're going to come down here and bounce at minus a, go through here and cut through a b, and that's what my graph looks like. I need to have a y-intercept. The y-intercept will be when x is equal to 0, so that will be a squared times b. So a squared times b is my y-intercept. There's my x-intercept, there's my x-intercept, and there's my graph. Okay, looking at part C, C is negative, A and B. So C is a multiplier at the front. So this is a degree 4. That's a negative on the x. That's a positive on the x, but C is the negative number. Negative times negative gives me a positive degree 4. Start up here and finish down here. So I might label my C's, A's and B's. I'm going to put C over here, negative, because I know C is negative. I'm going to put A here, I'm going to put B here. I could have put them in different levels of degrees away from, but A had to be smaller than B and C had to be smaller than 0. So I know I've got a SPOI at x equals B because it's to the power of 3 and I've got a cut at A. So I'm going to cut through at A, have a SPOI at B, and then continue up, and I'm going to relabel that to be A. And to find my y-intercept, y of 0 will be C times negative b cubed times A. That will be negative cb cubed, which will be a positive number because I know C is negative. And looking at D, I've got a quartic, and that quartic is a flat-bottomed quartic, like this, because there's only one x and there's only one factor. It's not really a factor because I've got a minus c, but it's been raised to the power of 4. But it's been moved, the turning point is at minus b minus c. And I know that A, B and C are all positive. So let's put my graph in. Let's call that A, let's call that B, let's call that C. Therefore that's minus A, that's minus B, and that's minus C. And let's make that down there minus C. Because the bottom of my fat-bottomed quartic is down here at minus B minus C. So we're going to have a graph that looks something like this, and I know that it's going to have some sort of x-intercept and some sort of y-intercept. 0 equals A, x plus b to the power of 4 minus c. C divided by A is x plus b to the power of 4. Therefore, x plus b equals the 4th root of c on A, and there's plus or minus of them because it's even. So x equals minus b plus or minus the square root of c on A. So this one here will be minus b minus the 4th root of c on A. And this one here will be minus b plus the 4th root of C on A, and to find this one here, it's going to be A times B to the power of 4 minus C, because when x is equal to 0, that gives you B to the 4, so A times B to the 4 minus C is what my y-intercept is.